Today's lesson, Lesson 3, Redox Processes, will be covering oxidizing and reducing agents. From last time, recall this problem where we had to write an equation for the reaction in which nitrate ions and copper reacted together in an acidic solution to produce nitrogen oxide and copper 2+ ions. Remember that we were able to decide that copper was the one being oxidized in the reaction and nitrogen the one being reduced. We followed the rules to balancing half reaction equations to determine the number of electrons and the moles of water as well as hydrogen ions required in both oxidation and reduction steps. We were able to multiply oxidation, half reaction, by 3 and reduction by 2 in order to equate the electrons both to 6 moles of electrons. That way, we were able to cancel out the electrons and produce an overall balanced reaction equation in blue. So now that we had a really quick recap, I would like for you guys to locate this problem on Nearpod and write the overall balanced equation for this reaction. My next inquiry for you is about neutralization reactions. Are neutralization reactions redox? Recall we mentioned neutralization reactions in topic 8, the past unit that we just covered from acids and bases. So are neutralization reactions acids and bases, reduction oxidation, or are they both? Give it a shot on the Nearpod as well. So oxidizing and reducing agents are different from when we say something is being oxidized or something is being reduced. Oxidizing agent is the reactant that accepts the electrons. So they bring about the oxidation of another reactant. So then they themselves are actually the ones reduced in the process. So oxidizing agents are the ones reduced in the reactant, and they help the reactant that is being oxidized. Here's a list of examples of oxidizing agents. Reducing agents, on the other hand, are the same. So they are reactants that are actually themselves oxidized, but they help supply the electrons to the other reactant to allow them to be reduced. Here are some examples of reducing agents. So what are the oxidizing and reducing agents of this chemical reaction below between calcium and tin 2+ ions? I'm going to give you guys a couple seconds to think about which reactant is being oxidized and which reactant is being reduced. All right, so from this, let's start by writing out the oxidation states. Calcium in its elemental state assigns a 0, oxidation state, tin 2+. We're able to see that calcium, in this sense, increases in oxidation state and the products 2+ and tin to 0. So in this case, it should be obvious that calcium is the one being oxidized and tin 2+ ions are reduced. When we refer to oxidizing and reducing agents then, calcium, the one being oxidized, is the reducing agent, and tin 2+ ions, the reactant that's being reduced, is the oxidizing agent. Reactive metals are stronger reducing agents. This means they themselves are more easily oxidized. Recall the reactivity series in which reactivity increases from bottom up. All of these elements, they all become plus ions, cations, which means they are a lot more easily oxidized. Activity series ranks metals according to the ease with which they undergo oxidation. So a lot of these tend towards the left, middle left side of the periodic table. Now, referring to what we just talked about with the reactivity series, why is the reaction below possible? Here is a hint for you to quickly refer to as you finish this question on Nearpod. So again, reducing agents increase in the same direction as the reactivity series. So as you increase in reactivity, so do you increase in reducing agent. So it means the reactant becomes more easily oxidized. Now let's take a look at oxidizing agents, which are they themselves easily reduced. Where do you think the oxidizing agents are located on the periodic table? Good. So they're usually on the right-hand side of the periodic table, right? We just said the reducing agents tend more towards the left-hand side. The oxidizing agents tend towards the right. Because they are more easily reduced, they like to attract electrons to their almost stable octet. So that's why they are more easily reduced. They usually take the form of anions as opposed to cations. Oxidizing agents, strongest ones, are in group 7, so they are the halogens. Halogens because fluorine is way too reactive. Fluorine is not considered in the oxidizing agent list. However, the general trend is that as you go up the group, oxidizing agent also increases in strength. So this means that chlorine in a reaction is able to displace bromide ions. Bromide ions are able to displace iodine ions. Therefore, halogens, chlorine, bromine, iodine, act as oxidizing agents. They are themselves easily reduced. They hold a negative ion charge. They're anions. They only need one extra electron to form a stable octet, therefore very easily reduced. Here's an example of what we just talked about, where chlorine is able to displace bromide ions because they are further up on the oxidizing agent series.